Okay, year one. Well, this is the second part of our maths lesson today. So in our first part, we focused all on volume. This part, we're going to be looking more closely at capacity. So let's have a go at our do now to see what we can remember from volume. Okay, so what I need you to do is I need you to order these by their volume from empty all the way to full. Now you can read these aloud and point. You don't have to write anything down. Putting me on pause, I'm going to give you a minute and a half. Off you go. Wonderful. So which one is this? Well done. It is empty. There is nothing in that container. Fantastic. Where is full? The yellow one. Well done. The yellow one was the fullest container. Where is half full? Right in the middle, the green one. We know that it's half full because the line would be half. Fantastic. So where is nearly full? The red one, the one closest to full. Fantastic, because it's not quite full, but it's nearly there. So where would nearly empty be? Well done. Nearly empty is the orange one that's left because it's got a little bit of volume, but not enough for it to be empty. Fantastic. So we're understanding capacity. We are going to be looking at different capacities and we're going to be comparing capacity. So let's remind ourselves what capacity is. Capacity is the total amount of liquid a container can hold. We say that when something has got it to full, we say it is at full capacity. However, if we were to put the same amount of volume of water into a different container, that was a different shape, it might have a different capacity. It might not necessarily be able to hold the same amount of water. So remember, volume is looking at how much is in the container, and we can change that by pouring some in and out. Capacity is the total amount of liquid a container can hold. A container can increase in capacity the larger it is. So we have an object that can have a greater capacity than another. So when we're looking at capacity, if an object is full, we can say it's reached its full capacity. There is no way we're going to fit any more water in the cup. Okay, it's reached its full capacity. But not all containers have the same capacity. If I was to compare two different containers, one container might be able to fit more volume of water than the other, which means they have a different capacity. And we can tell an object's capacity by comparing its shape and making a smart estimated guess as to which one would hold more or the least amount of water. So I'm going to have a look at some containers in my house and make some estimated guess at which one has the greatest capacity, comparing my objects. Here I go. Okay, so when we're comparing different capacities of objects and we get different objects of different size, we can see that they would contain a different amount of water. If I was to hold up this bowl and this glass, we know this one would have a greater capacity than the small glass, because looking at its shape, we can see that it's bigger and it would hold more. This is a smaller size and it would hold less. So this one would have a greater capacity. If I was holding up this glass and this teaspoon, we know the teaspoon has a smaller capacity because it would only be able to fill it a little bit of water in comparison to the glass. So we know the glass has a greater capacity than the teaspoon. If I was to hold up the bowl and this pot, looking at the two sizes, we see the pot is smaller. It would have the least amount of capacity in comparison to the bowl. The bowl would have a greater capacity. If I was holding up this and comparing it to here, we know this one would have the least capacity and the cup would have the greatest capacity, because looking at it, it is a bigger shape, which means it would probably hold more. Okay, so we're going to have a little try. I'm going to hold up two different objects and I want you to pick which one has the greatest capacity first. Greatest capacity. Are you ready? The bowl, well done. The bowl has the greatest capacity. The bowl, well done. The glass has the greatest capacity, well done, because the spoon wouldn't hold much. The glass has the greatest capacity, well done. This glass is a lot smaller, it wouldn't hold as much. This is actually a candle, but it doesn't hold as much. Okay, let's try least. Which has the least capacity? We're looking for something that holds the least amount. This time, the cup, well done. The cup has the least capacity, means it would hold less. Fantastic. The spoon has the least capacity, well done. The spoon would definitely be the one that holds the least. Which cup? Well done, this one does have the least capacity. It would hold less water than this one. Fantastic. Well done, this pot would have the least capacity because the bowl could definitely hold more water. Well done, everyone, and that is comparing capacity. Okay, so I've had a go comparing capacity. Now we're going to compare some capacity of these objects, okay? So we're going to be using pictures and using an estimated smart guess to see which we think has the greatest capacity. How do I know I'm looking for greatest capacity this time? Well, that is what the question down here below asks. It says, which container has the greatest capacity? So which of these containers would hold more water? A bathtub or a glass? Well, I think the bathtub would hold the greatest amount of water, which means it has the greatest capacity. I think I could definitely fit several glasses of water in a bathtub, which means this one has the least capacity. Okay, a swimming pool and a sink. Which one do we think can hold more water? Got a swimming pool and a sink. Which of these has the greatest capacity? I think the sink has the greatest capacity. No, why not? Because the pool's bigger? Absolutely. Do you think it holds more water? So which is the greatest? The pool has the greatest capacity in comparison to the sink. Well spotted, everyone. Okay, your turn. I'm going to help you here. We're going to do it together. This time we're looking for the least capacity. Which container has the least capacity? So we're looking for the container that would be able to hold the least amount of water. So we've got a swimming pool and a paddling pool. Which one do we think has the least capacity, is going to hold the least amount of water? They both hold a lot of water, but which one holds more? The swimming pool holds more water, absolutely. So which has the least capacity? The paddling pool, well done. This one holds the least amount of water, which means it has the least capacity comparing the pool and the swimming pool. Remember, we're always comparing because the paddling pool might have a greater capacity to a different object. Okay, what about this one? Let's read our question. Which container has the greatest capacity? Okay, you're going to have a go at this one. We've got a jug or a glass. Which one of these do you think will have the greatest capacity? You think the jug. Why do you think the jug has the greatest capacity? Because you think it could hold more water? Okay, and do we think we could put lots of glasses of water in the jug? Absolutely, well done. The jug does have the greatest capacity when comparing it to the glass. Well done. Okay, let's read our question this time. Which container has the least capacity? Okay, we've got a bathtub and a sink. Which one of these contains the least amount of water? Which one could hold the least amount of water? I think it's the bathtub. No, which one is it? The sink. Why do you say it's the sink? Because if we were to fill it up, the sink would have the least amount of water. Fantastic, well done. Okay, let's do some quick fire. Which one do we think can hold more capacity? The small cup or the larger cup? The larger cup, well done. This one has a greater capacity. Fantastic. Right, next, quick fire. Which one has the least capacity? A steel tub or a teaspoon? The teaspoon, why do you think the teaspoon? Because that would have a smaller amount of water or substance in it. Fantastic. Okay, next one. Which container holds the least capacity? Oh, we got 3 this time. A watering can, a jug of coffee, or a teacup? Which one has the least capacity? Okay, let's narrow it down. Which one has the greatest capacity? Well done. The greatest capacity is the watering can. Right, so now it's between the coffee jug or the teacup. Which one do you think? The teacup. Why do you think the teacup? Because you think lots of teacups would go in a jar? You would be absolutely right. Well done. That is the one with the least capacity. Okay, quick fire. Next one. Which of these containers has the most capacity? What do we think? The bathtub, the bottle of water, the glass of Coca-Cola? Which one has the most capacity? Bathtub. Why do you say bathtub? Because you think we could fit several of the other 2 inside it. Fantastic, well done. Okay, I'm going to have a go answering these true or false questions. The first question is looking at these 3 containers. It says, these containers all have the same capacity and the same volume. Okay, well, let's break this down. Capacity means they all need to be the same size. Yes, they are all the same size, so I can give that bit a tick. And they all have the same volume. Well, volume tells me if it's full or empty. Do they all have the same volume? Oh, well, I don't think they all have the same volume. This one's got more than this one. This one looks nearly full, that looks nearly empty, and that looks half full. So I'd say that this is false because it had the same capacity, but it didn't have the same volume. Okay, next question. The containers are all half full. Okay, well, let's look. Half, half, half. I'd say that's correct. But they have a different capacity. So now we're looking at the size of the objects. Are the size of the objects all different? That one's big, small. Yeah, they're all different size capacities. Is the question true or false? It's true. Well done. Containers are all half full, but they do have a different capacity. All right, let's do this one together. These containers all have the same capacity. So that would mean they'd have to be the same. What do you think? True, well done. They are absolutely identical. These 2 bottles would have exactly the same capacity because they are identical. Okay, next question. These containers are different sizes. What do you think? Yes, well done. They are different sizes. We've got a large one here all the way down to the same smaller one. Next part of the question. They all can hold the same amount of water. So we're saying this small one holds the same amount as this big one. No, why not? The big one has a greater capacity than the smaller. Well done. So is this true or false? Yeah, absolutely, it is false. Not every part of the question was the same. Okay, next question. These containers all have the same capacity. False. Why is it false? because they're all different sizes. So are they going to have the same capacity? No, they're not. Well done. Next question. These containers are different sizes. Are they different sizes? Yeah, absolutely. They all can hold the same amount of water. Now they're different sizes. Can they all hold the same amount of water? Would this one hold the same amount as this one and this one? You don't think they can all hold the same amount of water? Absolutely, well done. If they are different capacities, they cannot all hold the same amount of water. Fantastic. All right, well, you're going to have a go at your worksheet now. Remember, you need to circle which has the greatest and the least capacity, comparing the objects. And then if you want to have a go at a challenge, you can look for different objects in your house that have different capacities. All right. Good luck, everyone.